All right, so my presentation will actually give itself.
Hello. Today I'd like to talk about the exciting integration of generative AI tools in NetsBlox. NetsBlox is a block-based programming language based on Snap, and we've added some new features that allow for generative AI. We've added an AI music generator, which allows users to create unique and creative music tracks using AI. We've also added a large language model for text generation, which can be used for a variety of tasks such as chatbots, language translation, and more. We've also added text-to-speech capabilities, which allows users to hear the output of their code in a natural-sounding voice. Finally, we've added a stable diffusion-based image generator, which can be used to create unique and created images using AI. We chose to avoid using AI tools to interact with code for multiple reasons. The free models were not reliable enough for even code interpretation of more complex tasks, and we want to avoid total novices from relying entirely on AI-written code. We've also added new services in the existing remote procedure call blocks, which allow users to access these new AI tools. These services are not currently publicly available, but please contact us if you are interested in testing them. By using these new AI tools and NetsBlox, we hope to make programming more accessible and fun for everyone. Thank you for your attention, and I hope you're as excited as we are about the future of generative AI in NetsBlox.
Hey, so can you all hear me now?
Yep.
All right, good, thank you. Just wanted to make sure that I regained control from the AI here. So this presentation is actually entirely AI driven. If you couldn't tell from the images, the background music was generated. I apologize, the script is a bit of a mess. The text that used to read off was generated from a prompt I gave it. The music was generated from a prompt I gave it, and the background images, I set it up to take each line from the script and generate an image prompt and then an image using that prompt automatically. I actually don't know what prompts it came up with. I don't know if it was any good, but it's a demonstration of what we're able to do. The text-to-speech does have a bit of a issue where, in an attempt to sound natural, it seems to insert a lot of ums and uhs in its speech. More than I do, so it must be less confident than I am, but I think it does sound very natural. So again, we're focusing on tools to help students build creative projects, because a lot of the AI code generation, we have some things where we work with total novices often, and we don't want them to start from hello world being give me hello world. We want them to understand the basics before using tools like that. So this ties in with our existing services like Google Maps, or we actually have other image gathering services like NASA's Image of the Day that students can integrate into their projects and creative uses without it doing their project for them. All right. Thank you.
Hi, everybody. My name is Dan Garcia. I'm a teaching professor at UC Berkeley. What I want to talk to you today about is a project called, start my timer, Games Crafters and the GAMESMAN solver. So Games Crafters is a research group that I have at UC Berkeley to solve, perfectly solve, strongly solve abstract strategy games, like two-person strategy games. Here's my group of folks. You might recognize this wonderful young lady there. We've written a piece of software called GAMESMAN Uni, and it allows you to play a game perfectly. So if I play tic-tac-toe regularly, this is tic-tac-toe played perfectly. The colors here, it shows here, yellow is a tie, red is a lose, and green is a win. It tells you the value of playing this game, the value of a move. So it's a tie game. Players should tie. This means two perfect players should never have any of them win. It should be a perfect tie. It should be a tie. So if I move up here, it says that if O, tic-tac-toe, but if you don't know, this game is a game, it's also called noughts and crosses in other countries. It's a game of 3 in a row, and you take turns, and you can't place a piece on a position that's already been taken. And the goal is to get 3 in a row horizontally, vertically, or diagonally. So this says that if O places here, it's the only way to preserve a tie. You may not have seen this before, but maybe you've played tic-tac-toe in the past and you say, well, you know, if someone goes in the corner, you got to go in the middle. Yeah, that's because the only way to preserve a tie in perfect play is to go in the middle. If you do this, then it doesn't actually matter where X goes again. X can go here. And you'll see that, well, O has to block. If O doesn't block this, if O blocks, then this is a tie. If O doesn't block, if O goes anywhere but here, X could just win. So O would block here. And let's say if X goes here, well, not, let's say if X loses. So X can go here to lose. And these are winning positions. Now, this is all our software. I wanted to show that we have an API that is open to any client. You could write this in Python or in Snap. So what I have for you is, this is the exact game just with a front end, just a fun little Snap front end that calls the API to get responses. So you'll see this if I start this game here. So I play tic-tac-toe perfectly. Click to make your move, and it's just talking to my API. The same yellow you saw here is exactly the same yellow you saw, but it's going to play for me. And so I click this, and you see that, remember, yellow is in the middle. It's going to choose that. I'm going to choose this one. It'll say I'll choose slot 9. It kind of gives me some feedback, and I'm going to make the losing move here. And you remember when you went here, O could go any. You don't have to win immediately. If X goes here, there's no threat. O can actually go here or here, and actually O here or here and still win. We actually color code this with something called delta remoteness by having this be a little darker green, saying this is the better win. This is a little slower win, but you'll still win. So watch this. If I make this move in the corner, it might choose slot 8. So it randomly, I decided to remove the win as fast as you can model. So now it says, well, I'm going to beat you anyway. If you go here, it'll eventually come and win this game. Now, what's fun about this game, I still have a minute or so, is that you can, if I go back to this, play the Misère version of this. And the Misère version is where 3 in a row loses. This is a fascinating game. It breathes new life into this game. So it means that if you play 3 in a row, you'll lose this game. You don't want, you want to kind of put your pieces, and if you're going first, it's harder to avoid 3 in a row because you have 5 pieces to play. O only has 4 pieces to play. The only way of doing that is by moving in the middle in perfect play. You can play against your friend and still win if you do out here if they mess up. But in perfect play, the only way to do this is to go in the middle. So if I go in the corner, notice that O can go any one of the 4 edges for the win, to actually predict the win. So let's go over here, and I've added that feature here. If I hit the space bar, I toggle from Misère to normal. So if I click this and then turn this on, now I've got Misère. And if I do this, notice it color codes exactly as you saw the answer from the API. If I go on the side, it's going to then play perfectly. And whatever I try to do, you think, well, Dan, you should be able to put your X's in a row. Whatever I do, just watch O. I'm going to try to avoid as well as I can. I'm going to try to avoid getting this. Can I avoid it? Can I avoid it? I'll say, I'll go here. That's certainly pretty good. And then O goes there, but follows the green. And you'll see that I will eventually lose this game because it plays perfectly. It says I win, and then it restarts every 5 seconds. That's it. So you can hit spacebar to toggle between Misère and not Misère. You can stop and start. And that's my presentation. Thank you so much.
Hello, everyone. I'm Devin Jean, and I'll be presenting Ready, Set, Go, synchronizing projects on multiple computers. So for the sake of time, we'll just jump right into a NetsBlox overview real quick. So for those of you who don't know, NetsBlox is a fork of Snap that adds a few networking features, one of which is remote procedure calls, where you can access some web APIs that are curated by NetsBlox on the NetsBlox server. Those are less important for this. What we're mostly interested in this talk is message passing between projects. So students can package up tagged key value pairs, like they can make a data type, my data type, and have things like X, Y, and Z fields. And they can send these between two projects running anywhere in the world. Now, a lot of the projects in NetsBlox are distributed in nature, and these are pretty easy to make with NetsBlox. So here's a simple example of a client and server. So you can have the server send a message called new question out to all the clients. The clients receive a new question, they ask it to the user and send their answer back to the server. The server keeps track of the first player that got the right answer. So it's a pretty simple game like that. So as far as the background of this talk, we're going to be talking about multiplayer games and distributed programs. There are two problems with this. State synchronization, which is relatively simple. At least the types of programs that students are making typically don't have a difficult time doing state synchronization. They can usually handle that on their own. But what poses a bigger problem is time synchronization, which has some unique challenges that the existing blocks in NetsBlox weren't really capable of addressing. So take our simple example of a client and server for that game that we looked at before. If there are a bunch of clients, as there would be in this type of game, who will be the winner in the end, according to the server? We would expect it to be the first person chronologically to get the right answer, but in actuality, the latency between client and server varies for each client. One client might have a very low latency, so not only do they receive the questions earlier, they can actually send their answer more quickly to the server, so they'll have an upper hand. But we don't want that to happen. We have to add blocks so that students can fix this kind of problem and be able to do things simultaneously, even despite this latency issue. So this is a race condition caused by latency. Now you might be thinking, can't we do something where we schedule ahead of time? Like let's say we get the current time, add some amount of time, like 5 seconds. We send this time out to everybody. Everybody waits until that time, say 9 a.m., and then they send the question. So that should get rid of the problem, right? Well, a different issue is that there's clock drift on different computers. So 9 a.m. is not exactly 9 a.m. on other computers, and we don't really have a good way to address that currently. So our solution is time sync. There's an existing system to solve this problem called Network Time Protocol. So basically you have a client send a message up to the server and then it sends it back to the client. So by taking timestamps at different points along the way, we can compute some clock delta metrics. So our idea is to use the NetsBlox server as a ground truth for this. We deploy an MTP-like server on NetsBlox, and then to hide all of the complexity out of the way of students, we make a simple extension that can do this for them. So we have one block, calculate time sync info, which will do this repeated message passing to the server, compute time metrics, do outlier rejection, all this nastiness that we don't want to show the students. And then we have a block to get the time sync info, which includes the round trip and clock delta. And more importantly, the server time block predicts the server time given the local time plus the pre-computed clock delta. And using just those two left blocks, we can kind of fix the problem that we solved before. So here's a little short example. So we have a little distributed program where we can schedule an animation to start simultaneously on 3 different computers. And I have one that uses no synchronization, so just scheduling ahead of time in the future, and a different one that uses the time sync extensions, calculated time metrics, and server time prediction. So I just triggered all of the programs to calculate their time sync metrics. And here is the non-synchronized version. So you see that the bottom right started much before the other ones because its clock happens to be a few seconds ahead of the others. But even the others didn't start exactly at time. But now here's the one with time sync. And you see they pretty much all start exactly at the same time with minor fluctuation between them. And that's pretty much it for the talk. Here are a few resources if anyone's interested. It'll be posted online and I can answer any questions in the chat. Thank you so much for listening.